Today we're going to talk about marine diseases. It's a subfield of conservation science that's becoming more and more important. We're finding more marine diseases, particularly where there's high pollution, and we expect that diseases are going to become more common with warmer water that makes it easier for bacteria to grow. But let's talk a little bit about one of the best documented marine diseases in the world, the sea star wasting syndrome, with Dr. Pete Raimondi from the University of California at Santa Cruz.
I got it started from my advisor, who was a guy named Joe Connell at UC Santa Barbara. And he was a rocky shore biologist and ecologist. And when I went there, I got very interested in rocky intertidal, and I did my thesis work in rocky intertidal in Mexico. I came up here as a professor, and our group mainly looks at biodiversity along the West Coast, the effect of global change on that biodiversity, and the mechanisms that may be affecting the changes in the communities that we're seeing. It very much depends upon the species that you're talking about. And one really key thing to remember about sea star wasting on the West Coast is that virtually all species of sea stars were affected. Not all, but virtually all. And the symptoms really differed. The most catastrophic and dramatic were with Pycnopodia, where they would go from looking fine to being a pile of bacteria in 2 days, literally. They would just transform into what we call ghost stars, just an outline of bacteria on the seafloor bottom. The other species that was really affected and was very conspicuous is the ochre star, Piasaster ochraceus, and it took a lot longer because it's got a much more hardy skeleton or structure to it, and it would go from losing a tip of an arm to a lesion to losing a whole arm to splitting to 5 arms just walking around to decay, and that might take months to occur. And so in the end, most died. Not all species were as severely affected, but most were, and they just took longer or shorter in order to decay. They all decayed in the end, just at different rates. It's a very hard question to ask because we didn't know how many sea stars there were. We know that there was probably greater than 90% loss of Pycnopodia, the giant sunflower star, the one that's underwater subtidal. We know that that's probably the same for Piasaster ochraceus. It's certainly in the millions, maybe hundreds of millions. Again, we don't really know how many there were to begin with, but most of them were lost at one time or another, and some species have yet to recover in any substantial way. We thought that we knew. We thought it was a virus. It turned out to be wrong. One of the things that we do know is that the end, meaning when they die and the reason that they die, is probably not related directly to the disease or what caused the sea stars to become incapacitated. It's almost certainly due to bacteria. And so the progression is really that they are compromised in some way. We thought it was a virus. It's probably not. It could be other sorts of lesions. It could be heat stress. It could be viruses that are differing in different places. But then it turns into a wound of some sort. And once that wound develops, then there's bacterial infection, and it just rips through sea stars. They have very primitive kind of systems to deal with infections, and so it just rips through them, and then they die. I'm going to talk about two that are related to the two most affected sea stars. The first is Pycnopodia, which is the giant sunflower star. We think that it was a major predator on especially small sea urchins. And we also think that because they were lost in such great numbers and proportions throughout the range of Pycnopodia, which is basically the range of giant kelp and urchins, that the urchins were released by one of their major predators, and they just ravaged the kelp beds. And that led to barrens that have not recovered in many of the locations, especially on the north coast with bull kelp. The second is Piasaster ochraceus, and a lot of fundamental work had been done with Piasaster ochraceus showing that it was what we call a keystone predator, and that when you removed Piasaster, which is the ochre star, that mussels would take over the intertidal, That was fundamental work done by Bob Payne a long time ago. What we're seeing now is that is in fact happening. It's taken a while, it's been 10 years, but mussels are moving down. We are seeing mussel beds lower, meaning deeper in the water than we've ever seen them. They're covering up black abalone, which are an endangered species. Beaches are now being covered by mussel shells because they're so abundant. And so those are the two most pronounced implications in terms of the community that we've seen. We know that Pycnopodia is lost. It was mostly lost throughout much of its southern range from, let's say, Oregon south. And in those areas, they have not made any comeback whatsoever. They are coming back in Alaska and British Columbia, and some places they never went away. But in the areas where they haven't come back, the kelp beds remain about the same, which is in a depleted state, especially bull kelp, and in some places the giant kelp as well. It's a little bit different for the intertidal species, Physastrocrasis, because they have recovered episodically and kind of all over the place throughout their range. And in some places they're just as common as they used to be. In some places they haven't come back yet. But those communities where they have come back are behaving normally, and those communities where they haven't come back, it's what I said earlier, the mussel cover is expanding and the communities are still changed because of that. I'm not sure about the development of the sea star wasting disease, but the progression of it has certainly been accelerated by warm water. We went through a tremendous heat wave between 2013 through about 2015-16. That's when the wasting exploded in almost all of the stars up and down the coast. That's where a lot of the barrens started being initiated, and so for sure that warming accelerated the progression of the disease and the effects of this disease. Because we're not actually sure what the disease was caused by, it's hard to assign a cause to climate change, but we know that the rate at which the progression occurred was certainly due to warmth. One of the things that we're very worried about is that disease is going to become more prevalent, regardless of the taxa as we go forward. That's just the nature of things that end up, especially things that end up with bacteria, is that warm water, warm conditions in general, cause acceleration of spread, and that and this isn't going to be restricted to sea stars. We've already seen it happening in urchins. Black abalone are the same way, and they preceded them, and it was associated with warm water then from an El Nino. So I think for sure that there is a great need to do research into the transmission, the vectors, and ultimately the causes of all these diseases, because it seems like it's, if anything, going to get more and more common in the future. There really are, and in fact, one of the great triumphs of the sea star wasting period was that we initiated a website that allowed people to make citizen science observations. And it was a regularized and pretty easy to use website that had instructions about what to do when you saw a disease sea star. Everyone's got a phone, and so if you see something, the key thing is to take a picture and then send it to someone. And in fact, our website, which is just marine.ucsc.edu, has an interface for observations. And because of that website, we know more about sea star wasting than any other marine disease that has ever occurred, because we got thousands of citizen sci observations of disease and also non-disease when the disease was rampant. And so for sure, pay attention, take a picture, send it off, give us a location, and that will matter in terms of understanding the next event that is almost certainly going to evolve. One of the things is that we say this all the time in science, and we say it probably in public a lot too, which is everything matters. But I think a lot of people probably think, oh, this sea star dying here, this sea star dying there, doesn't really matter. And in fact, it does. These are the harbingers of things that might be coming much worse in the future. And I'm talking about it could be much worse next month, or it could be much worse in 10 years. But those observations are really critical for the smallest to the biggest thing, that you report these things and you let people that know what to look for understand that there are things going on in nature, because we can't keep track of it all, but you can.